So let's probably wait for a couple more minutes. So I see the people still coming in right now.
Yeah, hi Eddie, can you see my screen?
I cannot see your screen, but I can.
Okay. Maybe I can try again.
You can try to sharing. Yeah. Now I could. Yes. Let's wait probably like for a couple more minutes.
Okay, sure.
Yeah, we have 2 minutes past. I think we can start. I see a couple of folks already joined. So today, I think that we want to, like I say, continue from last time, the Hassan's discussion for the routes downloading, the performance analysis. So last time, Hassan described what he observed. So this time, I want Yubin from Alibaba to describe what Alibaba observed. So so that's for the today's agenda. Before we started, did anybody add any more some comments before that? Okay.
Were there any action items for the previous meeting, Eddie? I did not join that.
So for the last meeting, we did 2 of them. One is for the code review for the SRv6. So that we did a group review. Then after that, I sent the email out to the Microsoft guys. Then Yan Zhao helped to get a reviewer for that 2 PRs. So I'm still waiting for the PR to get approved there.
Okay.
Then the other one is Gongjian from the Alibaba basically describe the basically we final there are some communication enhancement. The first part it seems kind of finalized. It's basically how we want to basically decide. Basically, we want to use add a zebra policy to decide should we skip the kernel or not. That one I expecting like next week. There will be a couple of proposals from for the intern programs. So this is the one of the intern programs. And so we can get some more like an HLD review for next week for that one. Then
Awesome.
the communication part, I would say let's do it for the following week. So we can, I would like invite one of my colleagues to describe like for SRv6, the policy, what is the problem we want to solve. Then we can discuss how we can steering the communications and what format for the communication. That probably will be the second part for the Gongjian's discussion. But since we have a more concrete use case, it's more easy to discuss. Okay. Any other comments before we started the Yubin's presentation? Okay, so then let's go, Yubin. You can share.
Okay. Yeah. Okay. Thanks, Eddie. Hi, everyone. My name is Li Yubin from Alibaba, and today we want to share with you about some optimizations we made to SONiC for DCI scenarios. Yeah. In the past, we often focus on the DCN using our SONiC, but in recent years, we try to move our devices from DCN to DCI, always use the SONiC. And then And also we met some problems. One of the most important problems.
Sorry, we cannot see the slide.
Okay, I can share it again. Yeah, what about this?
It's okay, thank you.
Okay,
Can see it now.
okay. And after we move our device from DCN to DCI, we met many issues. One of the important things is that the root scale from 100K to more than 1 million. Yeah. After that, we need to focus on the coverage, performance, and root install performance. Another thing is that we need to handle the link jitter in DCI network. That will always cause some root changes in our software. So the target in our DCI devices is that because we have more than 1 million routes, right? So the route install and route changes performance need to more than 20K per second, 20K entries per second to make sure that we have enough time to do the coverage and route install. Another thing is that during the failover, we want to do minimize packet loss in our software. So, but in currently, the SONiC route install performance is only maybe 6K to 8K per entries per second. And we try to make sure that why the route performance is so bad in our current software. Yeah. Before we move to the SONiC, we try to do some analysis before the OC agent. We found that from the in the BGPD to Zebra and to FPM SyncD, the performance is very well in our analysis. It's more than maybe 100K per second to the FPM SyncD. And after the FPM SyncD publish message from to the FDB, we do some analysis in it. And first of all, we can see some occasion workflows in that. After occasion receive publish message from the FDB, the following things it will do like that. First, it will do pops from the Redis DB. That means we'll execute a series of Redis commands like spop and hset and hdelete to make sure that it can take the message from the queue to the DB entries. Then they add router information to the local message database and do some basic check and record it to the file. This file we always know this as the REST record. Yeah. And finally, you will do the mailing process to do task and do some validation check. And then finally, you will install route from entity bucket to ACDB. The problem is all of these actions is run in serial. So we do we add some timestamp in our source code to make sure that all of these stage the time usage of all of this stage, and we found that we can see the following pictures from the first line we do when the first message execute the route, because in this case we set the batch size to 20K, the 20K, and each execute can get the full of the data 20K. And from the first execute start to the second execute start, it always uses 2 seconds. Sorry, is there some noise? Hello? Somebody?
I think, Jeff, you need to mute yourself.
Yeah, thank you. Hello? Okay. Let's continue. And it seems that all of these occasion installed performance is only 10K per second. That's similar with our final end-to-end performance. So we think that one of the bottlenecks is in occasion workflows. And we add some frame graph in the occasion. We found that the POPs performance is always 40K entries per second, and do task process will always 20K per second entries per second. Always, and then a record is using 60K. So it seems that all of this one process performance is well, but because of the run in serial, finally the performance is bad. Yeah. And then the syncd is the same of the syncd. Syncd always do the pops information from ASIC-DB and call vendor side API to install route to the hardware. It's always run in serial, and we always do some analysis in this process. The left of the picture can show that we always add some timelines in each API callings, and we found that the red side of there are two parts of the time usage in this process. One of the POPs, another one is core SDK APIs. So we want to check that if the DB performance is bad, so that the POPs need to use half of time to do. So we add some Redis benchmark to check if the DB performance is bad. But finally, we check that after we use the pipe mode, the Redis benchmark seems that the performance is very well, always 3 million or 10 million requests per second. So we found that that's because of the bottleneck in the awk agent. So the syncd cannot receive the message. So the syncd need to wait sometimes after the awk agent handled one of the bug. So it needs sometimes to pause. Another thing is install the route to the SDK to the hardware. It seems that the performance is well, almost 20K per second. After that, we always do the frame graphs in the syncd. We found another thing is that the flash counter thread will use the same CPU core with syncd process. It will use almost 15% of CPU resources for flash counter. So one of the changes in our system, we suggest that make syncd run in an isolated core to make the almost 10% of the CPU performance improvement. Yeah. Because this architecture is we didn't want to change all of this architecture using Redis and using the Redis pub sub. So we just we find another way to bypass the route install and route changes in our DCI network. One of the features is that the delay up and delay down. That is a solution to prevent repeat route delivery when link jitters occurs. You can see these scenarios. Our core, in this picture, core is our DCI SONiC device, and it linked to the optical transmission equipment. We call it OTE. And then OTE will link to another OTE, which of the OTE is on the one cities. Two OTE will cross the different cities, and the remote OTE will link to always our DCI network devices. Because OTE devices have the backup link in different places, that means one primary link in place 1 down, you will switch to the backup link 2 in place 2. In this case, they have small packet drop in these scenarios, but this action will cause remote fault to our DCI devices. That will cause that some link flap in our device. In this case, if we receive this remote fault and do the link flap, we will see the route install and route remove and install again. They will cause a lot of route events in our device. So we add some new features called delay down. After we using the delay down and set the delay timer, because the OTE switch time is always maybe 100 milliseconds, it can switch from the primary to the backup. After we set the delay down timer to 200 or 300 milliseconds, when it received the remote fault, you are waiting small time to see if they have during this time you will have the link up event. After you receive the link up event, you will see you will ignore this down event. because of these features, we can ignore the link jitters in our DCI network. But we cannot set the delay down timer to a very large value, because because the link from the OTE to the DCI device is really down, it will cause a lot of black hole in here. Yeah. Another feature, we call it delay up. This to avoid shortened link flap caused by the capacity expansions. Yeah, it's the same, but we use delay down always in our DCI. Yeah. And another thing is we analyze for our route install performance. We do a small test to test the performance of the routing. We create 2 BGP networks and announce almost 100K routes from device to another device, and create another 100K flows from end to end. And after all of these route installed to the hardware, the flow will from 0% to 100%. During this time, we found that these figures, the up figures shows that when the route is delivered in batch form, there'll be sometimes for the route to stop delivering. That means the traffic does not increase. We have studied the reason for this. It's found that when SYNCD receive batch message from awk to batch mode, there will be obvious performance bottleneck. At this time, the CPU is fully loaded because of Redis has poor performance when processing multiple messages with a large amount of data. So after we change the SYNCD batch size to 1, but because the default size is 128, we change it to 1, it seems better. Yeah, we will never see the bottleneck in here. Yeah, another thing is fast coverage. We do some changes for the awk agent fast coverage. Because as we know, the awk agent have something special handlers when ECMP members down. It will in the awk agent, it will remove the ECMP members directly, and finally it will do some to make sure that the flow can switch to another ECMP members. But we feel strange that from 2019-11 to 2028-05, we initialized the executor as a subclass of select table does not initialize its own priority. As a result, when the message priority is queued later, the priority of the executor is always use 0. That means all of the event and the message and the notification will have the same priority. That means when multiple ports are down, because one port down will cause the large of route event changes. It will when all of the events using same priority, it will influence another port down notifications, so that they will cause a long time black hole. Yeah. So we do some changes in here. We enable the priority for each event and notifications. But we still meet some problems in here, because it will cause some deadlock problems caused by the priority preemption. It means that complex priority configuration will cause the deadlock problem. So finally we enable this priority, but list all of the message priority as 50, notification priority as 100, and finally route priority as 5. That means all of the install message we treat it as same priority, and notification we have the highest priority, and finally the route have the largest. This capacity can optimize the route black hole problems caused by too many routing message when multiple ports are down. Yeah, it's another changes in here. Yeah, but all of these optimizations point above are small optimizations, or it's not very good to face the road performance. Just do some small changes for that. Only by solving the limitations of single thread process routing message can the routing performance be improved better. Yeah, we can see that if we use the multiple threads run in parallel, maybe the performance in here will change from 10K to 20K. I think it's very good, but it's very hard. You need multiple thread handler in occasion or any other else. So we are trying to find a new architecture to support multiple thread handler. In theory, it can double the routing performance, but it will complicate the overall architectures and need to introduce a lot of mutex and any other operations. Or another way is not using FDB and ASIC DB architectures. We call it DB bypass. That means we can use Zebra directly call API to ASIC DB and to bypass the occasion, or using the different things to check the route and do some changes in here. Yeah, we are trying to do that, but we also need, we hope that we can get the help from the working groups. Yeah, so that is all of the talkings I want to share today. Yeah.
I have a couple of questions for you. So
Yeah.
one, I assume you're getting to 1 million routes, not by routing internet routing table, but by creating VPNs.
It's VPN route and the underlay route. Yeah.
So have you tested performance when where your overlay route or VPN route is available over more than one next hop, and you need to change next hop in case of failure? What performance do you see?
You mean install the VPN route or change the next hop?
Yeah, so you know 1 million route from one next hop, and then it goes away, and you need to change next hop in Zebra and then in hardware. Did you measure amount of time?
Yes, because in our scenarios, our routes will not only have the one nest hop. We always have the nest hop ECMP in every route. So after we do the route nest hop changes, it seems that the performance is better than the routing create. That means the route set performance is better than the route create.
But it's still pretty bad, right? So I mean, everyone who worked on real routers knows what prefix independent convergence is. It's a indirection that removes direct pointer from route to next hop to point to next hop group, right? And this construct doesn't really exist in SONiC. So if you're going towards 1 million route that could have more than one next hop, this is something we should definitely look into. Again, we've built indirection or prefix independent convergence on our commercial routers around 2013. So this is definitely something we need to look into here. Number two, when you have a CMP, Zebra has somewhat weird behavior. I mean, it's not weird. It is what it is, but it doesn't change the next hop groups. It deletes them and creates new ones. And whole process takes a lot of time, effort, CPU time, and really for no reason. Again, we know how to do it better on commercial software. So this is another point we definitely need to look into, not to overload the rest of SONiC infrastructure by constant stream of changes coming from Zebra when you need to resize ECMP containers or next hop groups.
Yeah, you mean the separated of the nest hop to the route table, right?
Yeah.
Yeah, it's another thing I want to mention. It's very good point to separate the nest hop group to end the route, but you need the Zebra's help, right? Because we have the API to change the nest hop, but do not have the control plan to do that. So we need the Zebra, maybe Zebra and to help to do the separated. I think it's
so. FRR implemented next hop groups 2 years ago, right? So the basic construct is there.
Yeah,
It's just the rest of SONiC infrastructure that doesn't understand it.
Yeah, but I think the problem is maybe the FR cannot receive the pot down, link down event, can it? Because the FR just receive the BGP down and do the route changes. But
no, so all the registrations are a Zebra, right? So you always register to track an IP address of interest. It could be BGP, next hop, and Zebra.
Yeah.
So anyway, from an optimization perspective, especially in VPN cases, this is where you're going to get really significant performance improvements in hundreds of %. The more routes, the better performance.
Yeah. All right. Yeah, Eddie.
Yeah, I agree with you, Jeff. So this is something like which Donna also suggested, right? They let the BGP to tracking the between the prefix and the next hop group. Once we do that from the BGP, then when any of the underlay routes, basic packet changing can be very easy to handle. We don't need to refresh the whole overlay routes.
Yeah.
Exactly. So you already have grouping, right, in Zebra. What you need to do is to create indirection where you flip pointer to new next hop rather than changing next hop as per route and working the tree. Right.
I think that one we probably don't Donna to have. From what my understanding is, we don't have that code in BGP yet. Zebra probably has it.
So, but what I'm trying to say is that would be probably the most significant improvement when you start looking into VPN routes and millions of routes.
Yeah, that will be helping for the convergence. That, and there's no doubt for that.
Yeah.
Because today the conversion was bad. There are two problems we normally routes. There are two problems. One is the loading time, one is the conversion time, right? So this one, I feel like this one is more like focusing on the loading time, because we are Yubin is evaluate. I think this is the same as what the Hassan's was a previous analysis to see where the bottleneck if we loading them.
Yeah, so again, we could use history, and at some point you must bypass databases and use shared memory to download routes from IMU to FIP. If you look at history, I don't know, probably Arista is the best example. Getting SysDB and putting everything in shared memory improved performance by order of magnitude. So not using AppDB as DB path, probably the right thing to do. We need to figure out right infrastructure for that.
That's something we probably need to discuss, because I'm a little bit hesitant to changing the DBs because that's big change. I would rather.
It is a very big change, but you know, as we grow up and become from, you know, data center switch with 20,000 routes, going to become a one device with millions of routes, this kind of changes potentially are, you know,
I would say like I would prefer, because if you see the Yubin's slide, I think on slide 6, which he described that all the DBs are read write is above the 20K. And let's assume we are initially like shooting for 20K. Then I would say before I reaching the 20K routes per second, I'm not changing the DB in the architecture.
Yeah,
but I would rather go to the 11th, his suggestion, like say, because right now we're using single thread to do the awk agent. So if we can cut into the multiple pieces to using multiple thread, it's complicated, but it's a low-hanging fruit from my point of view.
No, Eddie, I don't think it's a low hanging fruit, because we don't have a single thread and we can left and right access other ARC agent information and do stuffs now. If you, the moment you introduce multi-thread, then you need to deal with all mutexes and everything. So BRF is in separate ARC, and then, you know, but there are multiple things that we access left and right.
No, I'm not talking about, this is basically the pipeline model. So the basically say when I do the multi-thread, what I mean is like the pipeline. So you logically it's still the single thread. It just say like you are jumping from one thread to another thread. I agree, like I say, but if you're organizing your data, like I say, properly, you can avoid all these locking issues, because it's a pipeline eventually. It's not.
Okay. I agree that, you know, so, if you look at the ARC agent, there are two kind of operations happening. One is we go and try to read from from the Redis using the POP, right? That invokes a Lua script, and that itself has a lot of IO turnaround time. Then when we receive the data, we now actually go into the processing mode where the job is now CPU intensive. And these two actually run as a batch. So if there are two threads, one is actually always doing the POP and putting those into the M2 sync of the respective orgs, and let the other org actually run in the background in parallel, while the other thread, the IO bound thread, is actually just doing the POP from the AppDB. I think that is certainly very possible.
Yeah, that's straightforward. It's not going to impact anything, at least. Yeah.
Correct. And we can actually achieve the parallelism there.
Yeah.
Because for my past experience, I did something similar. So it's kind of like, if ideally, if you say like cut in half, then you can get a 50% reduction. But normally you can cut like say 60-40, those kind of things. So not 100, but it's still very big achievement. Because
Right.
you like I say what as you've been suggested, a lot of things it's good to have here or pointer, but each time it's only small, like say incremental enhancement.
Yeah. I just want to add one more point here. So last meeting when I presented the convergence numbers, we were suspecting that Zebra itself is slow in sending these updates. I went ahead and actually what I did in FPM SINCD, I decoded the message and then I did not push them into the AppDB. So it was like everything which is happening FPM SINCD as is, just that there's no Redis interaction. And what I could see is that Zebra is now able to push all the 1 million routes in 30 seconds, and which is same as actually the kernel. So what it means is it's not the socket or the latency in actually pushing the data from the Zebra to FPM SINCD, which is responsible for the slowness. It's actually the FPM SINCD and Redis interaction itself. And if you look at closely what happens with specifically the route table, it's not the regular STDB interaction where you write on one entry on one side and read from the other side. What happens is route table, we add the key into a set, which ensures that the key is unique. So, as the set grows, actually you have complexity and making sure that the uniqueness is guaranteed. And this is done in the Redis. The second is we write the underscore route table entry. So there are two jobs which are happening. And what I see is that FPM SINCD is mostly busy doing the pipeline, Redis pipeline flush, add or flush. Majority of the time it just is spent there. So what I'm trying to say is, even before we look from the org agent side and try to optimize, there's a bottleneck right in the FPM SINCD that it is not able to push as fast as it should.
So you are saying like between the Zebra and the FPM SINCD, the socket it is a bottleneck. You know what you mean?
It is not. It is not. I said
no, it's very fast. I think.
Right.
It's very fast.
Correct.
Almost 100 per second. Yeah.
Yeah, it's like within 30 seconds, Zebra can push all of the 1 million routes to FPM SINCD. If FPM SINCD is not writing into the Redis.
Okay.
But the moment the FPM SINCD starts writing to the Redis, the performance actually goes down drastically.
But in our test, we found that you can see the left picture. After the left picture, after the sixth rows, we can see that each org agent can receive the because the bench size in this case is 8K. After this, every time the org agent can get the 8K data each time. So I think the bottleneck is not in from FPM SINCD to FDB. Because the bottleneck is here, every time occasion should not get the full batch size data, right? But
so this batch size you're talking about the POP size?
Yeah, no, it's the org agent bulk bulk mode the batch size. Yeah, because the occasion pops the data is using the batch, right? You need to pop a batch
Correct.
size of
Correct.
each time.
There's a pop batch size. You're right. Okay.
Yeah. So the problem is each time the occasion can get the full batch data. So I think the bottleneck is not in here.
Yeah, but even if you increase the batch size, it should not actually make much of a difference, right?
Yeah.
Yeah, I mean, so increasing the batch size is not going to help. I think.
You can see that after we increase the batch size from the 8K to 20K, you always can get full batch size data. So that it seems that the FPM syncD to FDB is very, very fast. But the problem is that the occasion is handled very slow. So each time the batch size each time the occasion can get the full batch size data in here. Always we move from the 8K to 20K. It's the same. So yeah, you know, right?
Okay. Sure. I think our observation was a little different, where even though we tried to increase the pop size, you know, the overall convergence actually did not improve.
Yeah. It's the same in our side. Yeah, we moved the 8K to 20K. The performance from end to end should not improve, but that's because the occasion is the bottleneck.
Yeah. Okay. Just on the other point that Jeff raised about the convergence. So if you see Orc agent ports Orc, that has the handling of the port down event. And in fact, it updates the next hop group and removes that leg, which has gone down. So, you know, that fast convergence is already there. However, as you know, Alibaba was describing that because of this port priority and the route having the conflicting priorities, it may happen that because there are outstanding jobs like the route or MAC addresses to be processed, the port down event is not handled as soon as it happens.
Yes, because you are in the last queue. Yeah.
Exactly.
But I think in current SONiC version, this issue always happens in the current SONiC version. We feel strange why we not do some changes in here. Because in currently SONiC version 2023-05, I found the code, the issue seems always happens in here. So
I think this should exist from day one, right? I mean, it's not a regression. Yeah.
Yes, and so I feel strange for that.
Yeah, exactly. It's just that, you know, nobody has taken a look at it.
Should we raise a PR to resolve these issues?
Yeah, I mean, if you have the fix and as Venkat was saying, there are no bottlenecks, then yeah, why not?
Thank you. Okay.
Yeah, for this one, if it's a low-hanging fruit, let's probably just raise a PR.
Okay.
Yeah. Because this one will be benefit for everybody.
Yeah, but sometimes if the SONiC have the wrong priority configurations, it will cause the deadlock. Because sometimes if some applications need to based on the queue configurations, but the priority of these applications is higher than the queue, it will cause deadlock. This application is always waiting the queue, but queue cannot. Yeah, right. You cannot get the priority handler. So
correct. Yeah.
So I'm not sure if I enable the priority in the SONiC community code, it will cause something wrong in here. So I still because nobody will test the code for that.
Yeah, it will show up in different scenarios. Maybe the automated test may not be able to catch. Only when you run into a specific ordering or event sequence, you see that it's not behaving correctly or there is a deadlock.
Yeah.
Why we'll have the deadlock? Supposedly, if there's no message on the high priority queue, we should go to the low priority queue, right?
Yeah, I mean, deadlock is not the right term. Actually, it is like not the not the prioritized ordering as it should, right? For example, right now we are seeing that port event is not handled, but if we reverse the priority, maybe something else may get starved. So it's not deadlock, but starvation.
It just get delayed, right? Based on.
Correct.
Yeah, for example, Eddie, for example, they have two applications. You have one application waiting for the queue, but the priority of this application is higher. So, after we receive this application, but queue will not initialize finished. You are waiting the queue, but the queue message cannot get the scheduled because of the low priority, right? So you are always waiting for the queue, but queue cannot be scheduled. So that will cause the deadlock in here.
But that deadlock means that the high priority application is still consuming, right?
Yes,
That-
yes.
So that
Consuming,
means
not waiting something, but this something is low priority. It will cause the deadlock.
oh, I see.
Yeah,
I
I
see.
mean, it's not deadlock. It's basically you're waiting infinite
Yeah,
time.
yeah.
So
Always waiting, but not
waiting,
cannot
yeah.
get scheduled. Yeah.
Yeah, yeah.
Got you. Okay. So should we fixing this one in the community or just leave it as is for now? Because I feel it's a good one, but that need a lot of testing. I don't know, like Hassan, you guys already take something similar in your code base or?
Yeah, I think we are also limited by this. Maybe we try to do some optimizations, but I think we can go in a bigger forum and discuss this. Involve some more folks from different areas, not only the route. Because it's the heart of it, and there are multiple orgs and component owners, and need to really get the buying in from everybody else.
Then maybe we can come up HLD and then we raising this into the yeah.
Correct.
Probably like a document and see what we want to solving and see other guys' comments in the review.
Yeah.
Okay.
Makes sense.
Okay, then we probably like you can prepare a HLD for this one for this priority changes.
Okay.
Maybe shooting for the like say the 11 release.
Okay, I will.
So then let's at least raise a discussion to see who has the concerns. One, yeah.
Yeah, I will talk to you offline. Yeah.
Then the other one is for this multi-thread. I don't know if you anyone want to be interested for the design for this one. Yeah, I feel like this one could potentially give us like, because this is like say logically is cutting the one thread to the multiple thread software pipeline mode. So it should be kind of like a low hanging fruit. So if that's, I don't know if anybody will be interested to do the co-design on this. To see where we do the cut and how many thread we cut.
So the jobs for the interns that you're offering.
I can put one intern here if you want.
Yeah.
Because this is sounds like I say because or at least let's cut into two. For now, I think that the even is very aggressive. Cut it to 4 already.
Yeah, just do some example of that.
I feel like this one definitely can give a lot of because we just jumping from one thread to another thread. This should be a good enhancement. Yeah. If that's the case, if you ever think this is good, we can go for the HLD. Then maybe Hassan, I don't know if Venkata, you guys will be interested. We can discuss offline, then come up with some HLD in this working group before we present to others.
Yeah.
Yeah. Okay. Yeah.
Okay. Yeah.
So the interns can work on next up groups as well, Eddie, because that's going to reduce a whole bunch of like the number of messages you handle and process everywhere, right? So
I
that's
agree
going
with
to
you.
get
I
like
think
a
this is the
big
plan, right?
enhancement. Yeah.
I was planning to put one in. I feel like this one is way beyond intern group, so I would like to let one intern to start it. But we can see like which one. But the problem is like that one. I need Donna to help to do the HLD design because that one needed to go from from BGP all the way down. Because BGP at least need tracking the prefix with the next hop group, but Donna is on PTO right now, so he won't be back until the end of the June.
Yeah, so Donald has reasonably good view of what needs to happen on the FRR side. So
Yes.
in 2 weeks, we should be able to discuss it.
Yeah.
And maybe start some work.
Yeah, I think that one definitely I want to drive in it. Even not intern work, we can put some full time in later on to work on it. Yeah. So. So right now I put next week we have like three like proposal. One is the last time the bypass the kernel that basically adding the zebra policy. The other one will basically the memory reduction for the BGP pass extra info and also BGP pass info, which Donna suggested. The third one basically we pick the Donna's code for the BGP node breaking down. Also for the memory reduction. So that three we want to discuss for the next one. So three of my intern can start working on it. Then the fourth one and the fifth one, I was thinking like one is I can start with the next hop group, start from the flow control, but that I need to wait, or I will do this software pipeline. So that's one part we can do. The other intern, I want to do the combine the communication, which is towards the SRVC policy part. So that's why, like I say, the other week I want to like I say, have some proposal and discussion to see how we can consolidate all the communications. So for the routes, we are going to the Zebra, and for the BFD, we probably go directly. And also there are some discussion probably like when I need your participation also to see that where we handling the routes should be in the Zebra or should be in the FBM Sync D or should be in the OC agent. So that is something we probably want to discuss.
Okay.
Yeah. So that's something like I have in mind. I don't know if any other guys have other topics.
How are you tracking this, Eddie? Is it there on the wiki, a list of all these items that we are tracking, and who is taking this up?
Yes, I will today. If you're looking, maybe let me sharing that. That's a good. Let me bring up in the wiki. Let me open that up, and then I share it. I didn't. Looks like I need to quit. Somehow I never sharing before here, so I can. Yubin, can you like sharing this link I post in the chat?
Yeah, let me see.
Yeah, I posted in the chat. Can you sharing that?
Yeah, let me see. Sorry, wait a minute. Yeah, I can open it. Let me share the screen.
Yeah, share the screen. Yeah, because my I forgot to change in the permission, so I need to quit, and I don't want to quit right now. Yeah.
I will. So can you see the screen?
Yeah. Can you go to only the you don't have the wiki page?
No.
Ah, you didn't log in, or are you logging?
Yeah, I log. Yeah. It seems something wrong in my side. Maybe another one can help to share the screen.
Hassan, can you sharing that one? Oh yeah, now I agree. Okay, good. Thanks. Sure.
Yeah.
So basically, can you go to the project? Go to the end, the project, the program project. So right now I put the 4 of them here. And the first one basically for the BGP pass. This is for memory reduction. So we want to reducing the BGP pass the memory reduction. So this is something like suggested by like Donald, and also from Alibaba side, we already made some brutal changes, not because we just removing whatever we don't need it. So this time we do the more proper way to doing it. So this one we probably can reduce the BGP pass from the current 400 to be 100 something. So this is the one. The second one will basically BGP node breaking down. So this is something like Donna has a pilot code, but he has some issues. He want one of the intern to help to fixing it. So this one will basically reducing the, see that from the 196 to the 56 byte. That's what he suggested, which I sounded like it's a good memory chunk to be reduced. Then the last one, which I plan to put 2 of them. There will be basically 2 problems. One is basically the skip the kernel route insertion, which we discussed last time. So these 3 will be present next week for the HLD. And but for this one also have the communication, like say channel optimization, the part that one we will have the following week discussion to using the SRv6 policy as an example to show where we put those intelligence and how what kind of format we want to tracking between the FR and the SONiC. Then what the Jeff suggested for the next hot group changing, which is the third one in here. This is the big one. So that one I need Donna to give the HLD in the BGP. Then we going from BGP all the way down. So that's currently all my 5 like resources to be so put in. But the third one is a very big project, and this one probably will definitely need a full time to be involved for this purpose. So then today's one, I feel like Yubing's one is also good in, like because software pipeline, it's easy to control, and 12 weeks sounds a reasonable way to get to some result to show like, hey, how much we can get if, say, for example, we break into 2, how much we can say in the like reduced. So that's why I was thinking that to using that one to replacing this group change probably. Because this one will take time. So that's where I'm tracking for this project. But once they have the HLD, we will add more detailed information for the HLD page, and also basically then what's the progress for each of them. Yeah.
So Eddie, we track all the issues and the enhancement feature requests as part of the SONiC build image issues. Is it possible to create issues for these enhancements with some details so that we can, attach tag the HLD to the issue, and we can go from there? What is it?
So sorry, say again.
The SONiC build image issues, right? We create the issue first with the tag enhancement and put all the details. I mean, whatever you are describing here, right? The various projects, you can add a lot of details in the issues because we have those details as part of the slide deck, right? So we just need to put those details in the issues, and so that.
Gotcha. So you mean the SONiC build image, that repo, right? I created the. Okay, sure.
Yeah.
I can do that. I probably created this to start with. Yeah, that's good one. I said even today we have like I say 2 in the say 1 is for the priority. We want probably I will raising that one also. Yeah. Yeah, that's good. I was yeah, thanks, Venkat. That's a good
Yeah, yeah.
one. I was thinking that how we tracking the issues because we are across multiple repos.
Yeah, yeah.
Because normally if you stick with one repo, it's easier. You can always use that repo to tracking the issues. Yeah. So it's okay to using the build image, right?
Yeah, yeah. We use that build image issues is what there is issue triaging meeting is going from this issues folder only. So we are
Okay,
like looking at the issues and we
gotcha.
are talking to other vendors and stuff like that. Yeah.
Gotcha. Okay, because I know that they have the weekly meeting for the I think Xin is driving it, so that's why. Okay, I can add some there. Yeah. Good. Oh, okay, that's good suggestion. Anything else? So we are 5 minutes ahead of the schedule. So if there's nothing, then we probably can stop here. And we'll meet one next week. Yeah. Good.
Yeah, sounds good.
Okay, thanks. Thanks, everyone.
Thanks, everyone. Thank you.
Bye.
Thanks, everyone.
Thank you.
Bye.
Yo. What's up? There's pasta on the stove and котлетки in the fridge.